Alright, we're going to start off with a review question. We've done this question several times, so it's trying to emphasize how important it is. It's highlighted, so it's a test question, warm up. This lesson, I think, is the last lesson in Chapter 9, Vectors. A hypotenuse is 3 less than twice the longer leg. So we can see that the hypotenuse is being compared to the longer leg. Then it says the shorter leg is 1 less than the longer leg. So the fact that the longer leg was repeated twice and both of the other sides were compared to it emphasizes that, that's a lot of glare on that, emphasizes that that's what the variable is going to be. So we shouldn't have needed to give that hint right there. So the longer leg is going to be x. Remember, the legs are the perpendicular sides. So the hypotenuse is 3 less than twice that. So 3 less than twice that. We've been working on these expressions all year. And the shorter leg is 1 less than the longer leg. So it's going to be x minus 1. Alright, write an equation and solve for x. So we're focused on the 3 sides of a right triangle. So that's going to be the Pythagorean theorem. So that's going to be x squared plus x minus 1 squared equals 2x minus 3 squared. So we've talked before about the area model for multiplying binomials, which those of you who had biology can relate it to a Punnett square and genetic traits and Mendel. I think it was Mendel that did the pea plants and stuff. So that's going to be 4x squared, and this is going to be minus 6x, and this times this is minus 6x, and that times that is 9. But we also would be probably good if we knew the pattern for squaring a binomial. So the pattern for squaring a binomial is to square the first thing, then to multiply these together and double it, so that would be negative x doubled is negative 2x, and then square the last thing. So that's the same thing we could have done here. Square the first thing, multiply those together, which would be negative 6x, and double it, so it would be negative 12x, and then square that. Which, if we combine those, that's what we get. Now, this is 2x squared over here. So we're gonna move this stuff over here to keep our a term positive. So we're going to subtract 2x squared from both sides. So eventually this is going to be 0. This is going to be 2x squared. Now we're going to add 2x to both sides here. So it's going to be negative 10x. And then finally we're going to subtract 1. So that'll be plus 8. Okay. Now we can multiply this entire equation by 1/2, and that will make these numbers a little bit smaller for us. Now, we can only do that because we have an equal sign here. If we were just factoring this, we could not just get rid of the 2, could not just divide everything by 2. We could factor out a 2 and put parentheses and put a 2 in front. But that's a little bit different, and sometimes students get confused with that. That's why I'm talking about it. Now, this looks like it might factor. The quadratic formula always works, but sometimes it's a lot longer to do that if you could just factor. The problem is you can't always factor. So x and x, this is positive, that means they have to have the same sign, and that's negative, so that means that that sign must be negative. And then hopefully it's pretty clear that we have to use 1 and 4. Negative 1 times negative 4 would be positive 4. Negative 1 plus negative 4 would be negative 5. So it looks like our solutions would be 1 and 4 initially. But if you think about it, if you take this 1 and you plug it in here, we'd have 1 minus 1 is 0. And that doesn't really make sense to have a side of 0. Also, if we plugged in a 1 here, the hypotenuse would be negative 1. So that doesn't really make sense either. So we're going to cross that off. We don't want to erase it because we want people to know that we did get that answer, but we realized it was incorrect. So we discarded it. Alright, so now let's get into talking about vectors. So those of you who saw the movie Despicable Me, perhaps you remember that the villain in the orange tracksuit, his name was Vector because he had both magnitude and direction. I believe he mentioned when they were in the bank when Gru was trying to get his loan. Anyway, so as we look at some of this, the symbol for a vector is a half like a harpoon, kind of half arrowhead. So that's the symbol for a vector. A vector has an initial point. Initial, you know what initials are? They're the beginning letter of your first and last name, middle name. Your initials begin, the beginning letter, initial. And terminal, terminal illness, so that means the end. They also call airports terminals, which is kind of odd because flights begin and end at the airport terminal, but that's a little bit different. So terminal is the ending point. So when we draw a vector, we need to show that it has an arrow on it, and that's a solid arrow. So that's showing us that it's going from here to here. So a common application of vectors is air traffic controllers. When they look at the vectors of airplanes, they can see. So if two airplanes are flying and they can see that they're pointed towards each other, but one is much faster than the other one, so that would be represented by a longer, oh, you can't see this one. So we have a short one here and a long one here, and it looks like they're going to cross paths, but you could see this one is going much faster, so it's actually going to pass this one before it gets there. I don't know if that's helpful at all, but you could look up vectors in air traffic control. Maybe something cool would show up. Okay, when we write a vector, we make it bold. I don't know if you can tell that that's a little bit thicker, so that's one way we indicate a vector also. I skipped the magnitude. The magnitude is the length. And it says both direction and magnitude. So to do the magnitude, we just do the Pythagorean theorem to give us the length of that. And I think we've covered all of that. So magnitude and direction. Component form. Component form of vector is just two numbers. It tells us how far it moves on x and how far it moves on y. And the way we get those components are we subtract the end from the beginning from the end. And you'll see that in these examples down here. The direction of a vector is the angle it makes with a horizontal line. So you want to use the positive x-axis, and you want to go from the east here, starting from the east. So our directions, if you recall, are never eat soggy waffles. Never eat soggy waffles, to help you with your directions if you don't remember them. And so the angle of a vector, there's a couple different ways we could do that, but we're going to focus on this right here, the angle that it makes with the horizontal, with the x-axis. And we normally go counterclockwise on that, but we're going to use a technique where we compare the directions instead of that. Okay. P and Q are the initial and terminal points of vector PQ. Write the component form and the magnitude and find the direction. So we're finding three things here. So the first thing is it says write it in component form. So in component form, we started here and we ended here. So you take the ending point minus the beginning point. So that would be -3. You also can use a little bit of common sense and say if you were at 0 and you moved to -3, where did you go? You went left 3. So it would be -3. Left is negative and down is negative. Now we take the y's, and that's 5 minus 1. So that's going to be 4. So that's component form of the vector. Okay. Now, the next thing we were asked to do is find the magnitude. Okay, so the way we write that is the magnitude of vector PQ. And that goes like that. Now, when you look at this, this is going 3 to the left and 4 up. Okay, so you can draw that on here like this. Now, this is -3 and this is 4. Now the negative is just telling us the direction, so it's not that that length is negative. The lengths aren't negative. But anyway, this is going to create a right triangle, and that should remind you 3, 4. That should remind you of a Pythagorean triple. And we've talked about those over and over again, so hopefully we all are comfortable with that. That's going to be 5. So the magnitude is 5. And then the last thing that we need to look at is the direction. So the direction is going to be this angle right here. And so the way we do that is we put the two directions that we're dealing with. So this is north and west. So we're going to put north like that. And then we would put the angle. What angle north of west is that? Now, we're not using a calculator, so we would use the two sides that we were given in case we made a mistake finding the hypotenuse. So that's opposite and adjacent. So that would be the inverse tangent of negative 4/3. Okay. Now you're at home, and so you could use a calculator if you want to get that angle. But if we were in class, that's what we would expect on the test. Okay. If you're checking your answer in the back of the book or on Alex, you could use a calculator to actually find that angle. Okay. So now you ought to be able to do this again. We just showed you how to do it, so now would be the perfect time to pause and then you do it yourself over here. So that's going to be the ending point was Q. So 1 minus a negative 2. So that's going to be 3. And then we're going to have 5 minus negative 1. That's going to be 6. So that's component form. Okay. The next question was the magnitude. And they use the same letters, so it's magnitude of PQ in this situation. And this one is going 3 to the right and 6 up. So this vector is going like this. And that is 3 and 6. So if we think about that, that's going to be 3 squared plus 6 squared. A squared plus B squared equals C squared. Then take the square root of both sides. So that's going to be 9 and 36, which is going to be the square root of 45. And 45 is 9 times 5. So that's going to be 3 root 5. And now we need the direction. It's going north again, and it's going east. And we'll use tangent again, opposite over adjacent. The angle is the angle down that it makes with the horizontal, the vector and the horizontal. So that's opposite over adjacent again. That's going to be inverse tangent of 6 over 3, which is 2. Okay. Tangent of the angle equals 6 over 3. So the inverse tangent is inverse tangent of 2. Alright. So that's a test question. You know how to find all three of those things there. Alright, let's move right along here to the second page. It's just a 2-pager on vectors. So vector AB describes the velocity of an airplane. The scale is in miles per hour. Find the speed, and the speed is the magnitude. Same thing in this case. Alright, so we're looking for the magnitude of vector AB. Now, when you look over there, so there's the plane, so you can look over here, and this is 1, 2, 3, 4, 5, and this is 1. Now, if you think about that for a second, 5 and 1, that doesn't sound very fast for an airplane, so hopefully you notice the scale is by 100. So it's actually 500 and 100. Now, when you go to do that, if you think about it, you could factor out, so it's supposed to be 500 squared plus 100 squared. But both those can be divided by 100 squared. So we have 100 squared and then 5 squared plus 1 squared. Okay. I don't know if that's bugging you a little bit, so if you think, let's think about it. So 500 squared, okay? So that's 5 times 100 times 5 times 100, like this, okay? And now that's 100 squared, and that's 5 squared, so that's where that comes from. We could do the same thing with 100. Okay, so the square root of 100 squared is 100. Now this is 25 plus 1, so that's not really going to reduce for us. So it's 100 times the square root of 26 miles per hour. Okay. Find the direction that it's traveling relative to east. So it's going to be north of east. So that's like that. And that's also going to be tangent. So inverse tangent. So inverse tangent, opposite over adjacent, so that's going to be 1 over 5. And then when we get that, that would be in degrees. Okay, so two vectors are equal if they have the same magnitude and the same direction. Two vectors are parallel if they have the same or opposite directions. The magnitude doesn't matter. So if we look at this next example, it says which vectors have the same direction. So all you're looking for is, let's see, so this one and this one are pointing in the same direction. So same direction. So this one and this one. Alright, so that's vector AB and vector same direction AB and CD. Okay. There's a lot of letters on there. Okay, which vectors are equal? Well, to be equal, you have to have the same direction and the same magnitude. We can see these both go over 3up1, so they'd both be square root of 10. So that is going to be A, B, and C, D. Those are the only ones that could be equal because they had the only ones that had the same direction. Now, which ones are parallel? Well, parallel is the same or opposite directions. So that means that, again, AB and CD are also parallel. Now, we also have these two here, the same or opposite directions. So EF, vector EF, because it starts at E and goes to F, and vector GH are also parallel because they are in opposite directions. Okay, and let's wrap this up. So vector addition. So if you want to add two vectors together, if you want to add u and v together, you just add the x's together and you add the y's together. And every year we have some students miss this, and it is frustrating because it's about the easiest thing we can do. So what you could do is you could line these up underneath here. So it's 3 and 4. And then you're literally just adding that. So that's going to be 8. And -1 plus 4 is 3. And that's all. Alright, last one. So that's a test question. That's a test question. So wrapping this up. We have a jet that is flying 389 miles northeast, 550 miles an hour. The component form of that vector is right here. So go like that, and leave myself enough room. Barely. Okay, so those are the components. Here's the vector. So northeast means it's going that way. and it's flying 550 miles per hour. Now, this is 389 approximately, and this is 389. The component form of the vector, that's this right here. And the 550 miles an hour, that's right here. Okay, now there's a wind blowing from the west at 50 miles an hour. Okay, so the wind is blowing directly this way. So, wish I wouldn't have drawn that so close there. So that is going to blow the plane. So as the plane flies, the wind is pushing it even more in this direction. Okay, so that's the actual direction. That's where the plane is actually going to fly, on that blue line there, instead of the red line. So it's flying this way, but the wind is pushing it as it goes over here. Okay, so if you take the component form of vector v, which is 389 east and 389 north, and then you add the vector of the wind, and the wind is 50 degrees west and not north or south at all, so that's going to be 0. And you add that together, then that's going to be 439. This will stay 389. So that, this is right here. Represent the wind as a vector. 50, 0. Find the jet's new velocity vector s and the magnitude of s. So here's s right here, which would be the blue there. I guess I should have done that a different color. And the magnitude of vector v, s, is going to be the square root, oh no, I'm losing the blue, 439 squared plus 389 squared. And we'll just tell you we did that on the calculator. That's 586.550 miles per hour. You need to go to 3 decimal places there. Alright, it's about that time. Have a good day.